Good morning, good afternoon, all. This is the DLD for geometry for the October the 26th, the Thursday here. We're going to be working on lesson 4.1, classifying triangles. Before we get started, I do want to remind you, you need to complete the quiz there for today. That'll be for attendance purposes. That'll go in as a 1-point grade in Power School, and we'll also want to complete the homework assignment that we'll have that's associated with 4.1. So let's begin here. Classifying triangles. The first key concept we're going to talk about here is classifying triangles by the angles. First classification we have, acute triangle. Okay, an acute triangle has 3 acute angles. So you recall that the measure of all angles to be acute is less than 90 degrees. The measure of angles is less than 90 degrees. All of them are acute. Equiangular triangle means that all angles are congruent. The measure of all 3 angles are congruent. So they would all be acute angles. We'll also find out later on that they would all be 60-degree angles. So that's an equiangular triangle. All 3 angles are equal, are congruent. Obtuse triangle. Okay, an obtuse triangle. Classify an obtuse triangle. Of course, it's going to have one obtuse angle. It's going to the measure of one angle is greater than 90 degrees. So it makes an angle obtuse. Okay. Right triangle, of course, it has one right angle, so the measure of one angle is 90 degrees, is equal to 90 degrees. So we have acute, where all 3 angles are less than 90. We have obtuse, where one angle is greater than 90. And we have right, where one angle is equal to 90. Of course, we have those 3 acute angles, or the equiangular, where all 3 angles are congruent, and all 3 are acute. Now let's continue here. Classify these triangles here. In example 1, by angles, use the best description to classify each triangle: acute, equiangular, obtuse, or right. Of course, A here, all 3 of these angles I can see. Clearly, the measure of all 3 angles is less than 90. They are not all equal, so these would be considered an acute triangle. All 3 angles are acute. All 3 angles less than 90. Over here, triangle B, in this example here, I see one 90-degree angle. I see one right angle. So this is a right triangle. And continuing here, on to the next page. We can also classify triangles by its sides. Okay, we have 3 different classifications here. We have equilateral triangle, where all 3 sides are congruent, and you can see that here. All 3 sides congruent. We have isosceles triangles, where just 2 sides are congruent, or at least 2 sides are congruent, I should say. Scalene triangle, no congruent sides at all. So we can also classify triangles by its length of sides here. If point K is the midpoint of FH, so we're looking over here, F and H, K is the midpoint. Okay. Classify each triangle in the figure at the right as equilateral, isosceles, or scalene. Well, let's take a look. Angle or triangle FGH. I'm going to be doing some drawing and some erasing here. So let's look at triangle FGH off the bat. I see the FG is 5. Okay. FG is 5. Well, GH is congruent to FG, so that would mean that GH is also equal to 5. Okay. Well, what is FH? What is FH? Well, K is the midpoint, and KH is 2.5, so FK must be 2.5. FH is also equal to 5. If all 3 sides are equal to 5, that would make this FGH an equal quadrilateral triangle. Okay. Let's take a look at the next one here. Erase the triangle GJL. GJL. Okay, well, GJ we get is equal to 8, and we see that. That's clearly marked. JL, clearly 5. What about GL? Any way we're able to find that? Well, we know that HL plus HG, excuse me, is equal to LG. I should write that. LH plus HG is equal to LG. Well, LH is 3. HG is 5 because it's congruent to FG, so this is 5. That must be equal to 8. LG must be, or GL must be equal to 8, we have found. So we've got a side that's 8, we've got another side that's 8, we've got a side that's 5. So two sides are the same, that makes this an isosceles triangle. Lastly, let's look at angle F, or triangle FHL. The last triangle we have here, we're taking a look at FHL. We've got a side that is, well, what's FK? FK we said was 2.5, correct? So FH would be equal to 5. HL would be equal to 3. FL is equal to 7. All three of those sides, none of them are the same. So this is a scalene triangle. Okay. So that's classifying triangle. We had to do a little groundwork, use the angle addition postulate a little bit, but we got there. Lastly, example 5, we're going to find missing values. Okay, so find the measures of the sides of isosceles triangle ABC. So all sides contain x, so it's going to be useful for us to find x. ABC is isosceles. That means two of these sides are congruent. Okay, we can see here they clearly have marked AC congruent to BC. Okay, to be congruent means their measures would be the same, so we're able to say that 4x plus 1, meter here, 4x plus 1 must be equal to 5x minus 0.5. Solving for x, let's add 0.5 to both sides. Subtract 4x from both sides. So that gives us 1 plus 0.5 is 1.5. It's 5x minus 4x, so x must be equal to 1.5. So let's now find the measures. So AB is equal to 9 times 1.5, just substituting x, minus 1. So 9 times 1.5, calculator work, of course, 13.5. 13.5 minus 1 is equal to 12.5. So we found AB. Let's find AC. AC is equal to 4 times x plus 1. X is 1.5, of course. And added 1 here for AC. So 4 times 1.5 is equal to 6. 6 plus 1, of course, would be 7. So AC is equal to 7. Lastly, we need to find BC. BC is equal to 5 times x, which is 1.5 for x, minus 0.5. So 5 times 1.5, 7.5. 7.5 minus 0.5 would give us 7. Okay? And then we see, yeah, we have an isosceles triangle. AC and BC are congruent. This is what we should have done. And then we found that AB is its own length there. So two sides of the same length. Okay, we found all the measures of the sides. Good to go. Okay, let's continue. example 6 here, coordinate geometry. We're going to find the measures of the sides of triangle X, Y, Z, and classify each triangle by its side. Okay, here it's going to be useful that we know the distance formula. The distance formula is the difference in X values. So X2 minus X1 squared. Oh, yes. Oh, this technology's messed me up here a little bit. Let's just start over here. So again, the difference in X values, so X2 minus X1 squared plus Y2 minus Y1 squared. We should be familiar with using this. Square root of sense. Or all of them. Excuse me. So that's our distance formula. We know that. We're familiar with that. Now let's apply it. So we want to find how long x, y is. Well, let's find xy. X2, so we're taking the square root here of, we're going to work on 43. We'll come back to 44. Actually, I'll probably save 44 for you guys. It'll be very similar to the problem we're doing. We're just applying the distance formula. So let's find xy, though. Xy, the x2 value is going to be 2. So 2 minus x1 is -5. Double negatives, so we do addition in a moment. We're going to square that. Then we're going to add y2, 1 minus y1, 9. We'll be squaring that. So this simplifies to 2 plus 5 is 7. 7 squared is 49 plus 1 minus 9. 1 minus 9, of course, -8. -8 squared, 64. 49 plus 64 is equal to 113. Okay. Square root of 113 is equal to, we'll go to one decimal place here, 10.6. Let's find, we found xy. Let's go back. Let's find another side of this triangle. Let's find xz while we're at it. Okay. Xz is going to be equal to the square root of x1, -8, minus x2 is -5, so minus -5, of course. Adding plus y2, 3, minus y1, 9 squared. So we're going to simplify this. -8, this is a plus 5. So -3 squared, of course, is going to be 9. Plus 3 minus 9, -6. -6 squared, 36. 9 and 36. It's going to give us the square root of 45. Square root of 45, of course, 6.7. All right, we've got to find one more side length here. We found xy, we found yz, or xz. We now need to find yz. So we'll be looking at yz. Okay, so to find yz, actually I'm just going to work over here. So yz is equal to the square root of, let's go with x2, -8, minus y, or x1, excuse me, 2, square that, plus y2 is 3, minus y1 is 1, squared. So this simplifies to, well, -8 minus 2 is -10. -10 squared, 100, plus 3 minus 1 is 2. 2 squared is 4. So square root of 104. We know that's not going to be equal to the square root of 115 or the square root of 45, but nonetheless, let's just take a look here. The square root of 104 is equal to 10.2. Rounding to 2 decimal places there. So all 3 side lengths here, we've got XZ, we've got XY, and YZ. All 3 side lengths are different, so this would be a scalene triangle. Okay. Thanks for joining today. Your assignment here, practice 4.1, that's in the module as well. You can work that on a separate sheet of paper. Don't forget the quiz, the assignment. Okay. Be good to go. Enjoy your weekend. Enjoy your DLD day. Have a nice afternoon. Thank you.